to dividing with area models and partial quotients. They go hand in hand, that's why we're doing the video together. They're very, very similar. So you're just breaking them apart with place value, just as you would do with normal standard algorithm. And this is lesson 5, session 4. And don't forget your date and your number. So if I look at this, let's start with the area model. Now, the area model is just like the one with your multiplication area model, where the middle part represents your area, and the outer perimeter of the top and the bottom is going to represent your factors. So, just like before you would do factor times a factor equals the product in the middle, but just switch it up a little bit, and now your dividend is what's in the middle. Your divisor is on the outside, and your quotient is going to be at the top. Now the reason for this is because we're using inverse operations. You have a dividend in division, and it's divided by your divisor, and it equals your quotient. That we know is true. Well, in multiplication, we have a factor times a factor equals a product. And you'll notice that I color-coded it. So up here, your dividend is your product. Your divisor is a factor and your quotient is a factor. So orange and orange, pink and pink, red and red. So here, normally your product is in the middle because it's your dividend. And up top is your quotient, and that's usually a factor. And on the side is your quotient, that's usually a divisor. So the problem that we're going to work with today is 504 divided by 14. And we're solving for our quotient. Now, if you look, our dividend's 504. So this whole thing needs to equal 504. Our divisor is 14, and we do not know our quotient yet. That's what I'm trying to find out here. So I'm going to think about to estimating. And estimating says I would take my divisor, and when I take the divisor, I would find quick facts that I could use to help me solve the problem. And if I look, I know I won't be starting in the hundreds place because I have a 2-digit divisor, and this 5 cannot, if it's a flat per se, I can't put that 5 sets of flats into 14 groups without fair trading. But I can do 50-10 rods. So I take the 50-10 rods and I can split those into my 14 different groups. So I'm going to start my first digit is going to be placed in my 10 spot. So 14 times 10 is where I'll start for my estimation. And 14 times 10 is super simple, 140, because we're moving place values. Then 14 times 20 would be 280. 14 times 30 would be 420. And then 14 times 40 would be 560. So now I can stop because I have 504 would fall in a number line, if this was a number line. 504 would fall in this sweet spot right there. So that's dividend would go right here in between 420 and 560. I was like strawberry butterfly, but of course it's not necessary. And that means that my quotient has to be between 30 and 40. So I know I'm not going to use 40 because 560 is greater than 504. So I'm going to go my lower sets of 10, which is 30 because I have 420 here. So I can split apart my area model. And I know that if I multiply 14 by 30, that's going to give me 420. So all I did here was 14 times 30 to get 420. Now, the over here would be the difference. Remember, the whole thing equals 504. So if I have 504 for this whole thing, and I take away 420 in this rectangle that I've created inside of it, that leaves me with 84. So over here is 84, plus 420 plus 84 equals 504. And this entire area is worth 504. Now, 84 is a product of 14 times something. I'm not sure what it is, but I have a good idea that it's probably greater than 4 because 14 times 40 is 560. So that means 14 times 4 is 56. So I'm thinking it's probably around 6, and 14 times 6 is 84. So now, up here I have 30 plus 6. My quotient equals 36. And I know if I divide 504, 504 divided by 14, it's going to equal 36. And I can also multiply 14 times 36, and my product will equal my dividend of 504, or 504, because they're inverse operations. So that's it for area model. We're going to flip the page on over, and we're going to do partial quotients, which is quite simple, similar to area model. It's just not drawing the model. It's doing the problem out in a division simple sign. So I have my 504 partial quotient. This is my title so I don't get myself confused. And just like in multiplication, I'm going to draw out that long line so I can separate and I don't get my math confused with my numbers that's going on there. 14 is my divisor still. Same dividend, same divisor. We're going to hopefully get that same quotient. So I know that I don't start in my hundreds with my initial digits only going to go, my first digit will only go in my tens. So I have 14 divisor times 10. My first set, that would be 140. Yes, I can subtract that. I have 4, take away 0 is 4, and then I fair trade 100 for 10 tens, and now I have 10, take away 4 is 6, and then 400 take away 100 is 300. So I say to myself, self, can I do another set of 10? And the answer, of course, it's yes, because 4 times 10 equals 140, and I still have 364. So 14 times 10 again would be subtracting 140. Now I have 4 and 0, or 4 take away 0 is 4. 6 take away 4 is 2. And then 300s take away 100 is 200s. So I look here, 224. Is that greater than 140? My 14 times 10? Yes, it is. So that means I can do another set of 10. So 14 times 10 is 140. I subtract that. 4 take away 0 is 4. 2 tens take away 4 tens is negative 2 tens. So I need a fair trade. 12 tens take away 4 tens is going to be 8 tens. And then 100 take away 100 is 0. Now I have 84. Well, 84 is less than 140. So I'm not going to do another set of 10. I'm going to do a quick fact of 14 times times a 1. Now you can judge for yourself what a basic fact is and how easy it would be for you. I feel like the easiest thing for me to go to would be times 2. If you think that you already know 14 times 5 and you want to do that real quick, that's totally fine too. But 2 is easiest for me, so that's why I chose 2. And the 10 up here was easiest because I know that I start in the tens place with my first digit of my quotient. So 14 times 2, I know equals 28. So I'm going to subtract 28. 4 take away 8, well, that's -4. So I'm going to fair trade that for 10 ones from 1 10 rod. And 14 take away 8, well, that's going to give me 6. So then I have 7 10s take away 2, which is 5. Now that's 56. I still have enough to look at this and say, well, 56, I could do another set. 14 times 2 would be 28. So when I do that, I have 16 ones take away 8. That gives me 8. And then 4 10s take away 2. That's 2. So now I'm left with 28. Can I do another set of 2? Well, yes, I can. If I couldn't, I could switch down and go to 4 times 1. But since I can do times 2, I will. So 28. 8 take away 8 is 0. 2 10s take away 2 10s is 0. So I have a remainder of 0. And I'm going to count up here what my quotient is going to be. Now, I have 10, 20, 30, 32, 34, 36. My quotient is 36. And you may be wondering why I didn't count the 14s. Well, the 14 is my factor because of my divisor. So I don't count that. I only count my factor that I'm using as my quotient. So 10, 20, 30, 32, 34, 36. That is my quotient. And that's it for partial quotients. If you notice, with partial quotients and area model, we arrived at the same answer. We just did it a different way.